All right, this is the 8.4 video lesson for just the introduction and the first example. So this is solving systems by elimination with multiplying first. So you learned in 8.3 that you can solve an equation using elimination by just adding two equations together. Well, I told you that that's not always going to work out so nicely. It's not always going to just happen to be that when you add those equations, something will eliminate. So we might have to do something to it first. So in that first section, you learned that you could multiply one of the equations by -1 if it wasn't going to work, and then it still worked. Well, what if just multiplying by -1 wasn't enough? So we're going to tackle problems like that because really most of the time, that's the type of problems you will get. So let's just ignore that example first of all. And so my question is, what if the two equations we were trying to solve using elimination didn't have the same coefficients, so the numbers in front of the variable? So what can we do? So in that last lesson, you had something like 2x and the other one would have -2x. Or if it didn't have that -2x, right, we would multiply that one of the equations by -1. So what if that doesn't happen? What if it's not that easy? So I want you to remember that what we do to one side, you must do to the other. And that's the same thing. We talked about that in last section as well. So what are we going to do? We're going to come back and fill in these steps after going over that completed example. Okay, so let's look at that example that's actually completed for you and walk through it. So if you notice, we've got two equations with the same variables, so that's our system. And if we add them together, notice that nothing happens. So when we add 2x plus 4x, that would give us 6x. And then 30y plus 10y gives us 13y, because remember, we're adding left side to left side, right side to right side, so we combine like terms, both on the same side, like terms on the same side. And look, that didn't do anything. So we're not going to do that because it didn't help. It didn't eliminate any variables. So why in the world would we do it? Okay, now multiplying one of them by -1 won't work either, because if this was -2x plus 4x, that still doesn't zero out. And -3y plus 10y doesn't zero anything out. And even if we multiply the second one by -1, -4x plus 2x would not zero out. Same thing for -10y and 3y. So nothing is going to eliminate if we just add them or if we multiply by -1 and add them. So what else can we do? Remember that we can do anything we want as long as we do it to both sides of the equation. So what could we do to one of the equations so that the coefficients of one of the variables are the same number but opposite signs? So if you look, it would be really easy. Here we have 4x. It would be really easy to turn this 2x into a -4x. We can do that by simply multiplying by -2. So we're going to take that top equation and multiply it by -2. So I'm going to put it in parentheses because I need to make sure that I distribute on this side since I have two terms. And on this side, I'm just going to put it in parentheses for consistency. So multiply each side by -2. Remember, that's okay. We can totally do that because we're doing it to both sides. So that's allowed. As long as we do it to both sides, we can do whatever we want. So then when we do that, -2 times 2x is -4x. -2 times 3y is -6y. And then on the right side, 12 times -2 is -24. So that's our first step that I have written down there on the completed example. So nothing will eliminate, whatever will we do? So multiply the top equation by -2 so that the coefficient for x will be -4. And don't forget to distribute. And we get that exact same equation that I had, except that I do see a little error here, and I will have it fixed on your copy. This is supposed to say -24. Okay, so we get that same thing. Now, remember, we're keeping track of our equations. So that was equation number 1. And so here's equation number 1. Now I'm going to add it to equation number 2. Remember, we don't add an equation to itself. And so when I copy that down right underneath of it, now you can see this looks exactly like the types of equations that you were given at the start of lesson 8.3. Now when we add, those variables will eliminate. So let's do it. -4x plus 4x will zero out. a negative 6y plus 10y gives us a positive 4y equals, and then make sure you keep track of your equal signs here. And then negative 24 plus 4 will give us negative 20. And then you can see we can finish solving just like you did last section. So divide by 4, so y equals negative 5. So let's go through and see what that completed example says. So it says that same thing, adding them together. We'll get rid of that here. And then you can see that I actually didn't go any further here to solve because it's the same as always from there. So the only difference was we had to take one of those original equations and multiply it by something, whatever you want, whatever you need to, so that the coefficients of one pair of variables, so either the two x's or the two y's, are the same except one's positive and one's negative, because those are called additive inverses. So when you add them together, it becomes 0, and that's where the elimination comes in. So that's exactly what we want to happen. So let's come back to our notes here and fill in what we just went over. So the step 1 is to multiply one or both. So that's going to be something that's a more advanced problem. You will do that all the time in algebra. Right now, we're going to pretty much stick to you only having to multiply one of the equations by something. So multiply one or both of the equations so that the coefficients, so the numbers in front of the variables, match, except that one is positive and one is negative. And then step 2 is to add the equations to eliminate, and then solve as you normally would. So just to give you a quick example of why you would need to multiply both equations by something, if you wanted to take this system and eliminate the y's, notice there's not a nice number you can multiply 3 by to get 10, or to get multiply 10 by to get 3. So what you could do is multiply the 3 by, this top equation by 10 to get 30y, and the bottom equation by negative 3 to get negative 30y, and then combine them. But let's do the easier thing and just get rid of, the x's, because it's easier when you only have to multiply one of the equations by a number. So that's it. That's your additional step, is that you've got to multiply one of those original equations by something so that you get coefficients that match, but one's negative and one's positive.